Good morning, everybody. So today you just have a video to watch, and then you'll have a homework assignment tomorrow that goes along with this video. I do recommend, though, this video, you're going to follow along with a piece of paper and pencil. You do not have to submit that, but being able to practice on your own, as you guys know, makes a big difference versus just watching me do it. That doesn't always help, right? So, all right, so first I want to do a quick warm-up to help us remember how to simplify square root expressions, thinking back to quadratics and how that worked with the quadratic formula. So if you would pause the video, try these 3 questions using the calculator, simplify them as much as you can, and then unpause it when you are ready to see the answers. All right, so my perfect squares are 1, which doesn't really count when you're simplifying, right? 4, 9, 16, 25, 36, yada, 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 all the way up to 100. 121 and so on. Okay, so for square root of 80, I believe I want to divide that by 4, but then I get 20, so I feel like there's something bigger. So maybe divide by 16. Haha, that works. So I can split this up into 16 times 5, and the square root of 16 is 4. So the 4 can be, like the 16 can be pulled out and turned into a 4. We don't know what the square root of 5 is really nicely, so we just leave it kind of trapped under the radical. For 54, I feel like it divides by something weird like, well, not 36. 16 maybe? Nope. 9? Yep, 9 and 6. So the square root of 9 morphs into 3, and we don't know what the square root of 6 is, so it just stays under that radical. All right, 180, for sure, let's see. For sure divides by 9, but I get 20, which is kind of big. So maybe 36. So 36 times 5 works. Square root of 36 is 6, so you pull that out. Okay, so just a quick refresher from our quadratics units that is going to come into play with what we do today. All right, we can also simplify square root expressions that have variables in them using exponent properties. So I know, dun dun dun, exponent properties come back to haunt you. Well, so the first one's not too bad. If you square root x squared, you just get x, right? Square rooting something that's squared is the opposite. It just kind of cancels it out. The reason for that is if I do x times x, I get x squared. So when I go to take the square root of this, that's what square root means, is what times itself gets me that number, and that's where that answer comes from, okay? So here's where it gets a little more complicated. When I have things like x to the third, what I want to do is I want to split it up into as many x squareds as I can, a lot like what we did on this slide. Like you're splitting it up into perfect squares, right? So why don't we split these up into perfect x squareds, because that did not seem too bad. So if I split this up, x to the third is the same thing as x squared multiplied by 1 more x, right? X squared times x gets me back to x to the third. Then we're going to do the same thing we did in that warm-up. The square root of x squared is x, so that's going to transform. But we don't know what the square root of this x is, so it stays trapped under the radical. So let's do another one. X to the fourth, we can split that up into x squared times x squared. Well, the square root of x squared is x, and the square root of the second x squared is also x. So there's nothing left under the radical. So my answer is just x squared. If you don't see that, if you're saying what times itself gets me x to the fourth, well, x squared times x squared gets me x to the fourth, right? So that's where that answer comes from. That's what it means to square root something. So let's do x to the sixth, same idea. I can split that up into x squared, and x squared. So I think something similar is going to happen, but this time I'm going to get x to the third. Again, if you don't believe me, what times itself gets me x to the sixth? Well, x to the third times itself gets me there. So that's why when you take the square root of this guy, x to the third is the answer. So let's combine all these guys together. What you're going to be asked to do on your assignment tomorrow is to simplify an expression like the one you see here. It seems really scary at first, but if you break it up into little sections, it's not so scary. So for example, I'm going to use a lot of different colors here. If I just focus on the 90, 90 divides by 9, so I can split that up into 9 times 10, because I know 9 I'll be able to turn that into a 3 eventually, and the 10 will stay put. Now I'm going to focus on the x to the third and do what we did on the last slide. I can split that up into x squared times x. The y to the fourth, I can split it up into y squared and y squared. And z to the fifth, I can split that up into z squared, and then one more z at the end. Then what you're going to do is go through and figure out which things you can take the square root of. So square root of 9 is 3. I don't know what square root of 10 is, so I leave it put. Square root of x squared is x. Don't know square root of x. Square root of y squared is y. Square root of y squared is y. Square root of z squared is z. Square root of z squared is z. And I don't know what the square root of z is. So then what we do is we take all the stuff that's left over and we keep it trapped inside of that radical. The last thing I want to do is reduce that, make that look a little nicer. So I'm going to make that 3xy squared z squared with the 10xz inside. So I know you're wondering like, wow, okay, going from here to here, how does that look simpler, right? Like it actually looks worse. The main idea is as you're simplifying down the road and when you go to learn new concepts, there is a purpose to this. Right now it seems kind of weird because I don't have as much time to dive into it as I normally would with you guys, right? So you just have to trust me that this is a skill that will come back in Algebra 2 that you're going to want to work on this year, okay? All right, so what if we're adding and subtracting square roots? So if I look at this first one, notice how all these square roots are square root of 2. That's awesome. Essentially, it's almost like writing this like that, saying that x is square root of 2. So what we would do in this case, we'd say, well, 5x plus 7x is 12x. 12x minus 6x is 6x, right? So what we do with radicals is kind of the same thing. If they have the same exact square root, we can combine them. 5 square roots of 2 plus 7 square roots of 2 is 12 square roots of 2. But then if I take away those 6 at the very end, I get 6 root 2. So it's kind of like, I almost like imagine this in my head as I'm doing the calculations. Here's what's a little bit tricky. Notice this one on the right. Some of them have the same square roots and some of them don't. So what I imagine for this one is I imagine the square root of 7s being x's and the square root of 11s being y's. So if I were to combine that, that would turn into 14x minus 1y, right? So it's kind of the same idea. If I go to combine these guys, I'm going to put the square root of 7s together. So 10 square root of 7 plus 4 square root of 7 is 14 root 7. And then 5 root 11 minus 6 root 11 is negative 1 root 11. Now I don't actually need the 1 in the front, so I can just write it like this, and then it looks just fine. Okay, you can also write it like this, where you put the square root of 11 at the front. Just make sure that your symbols correspond and you're getting the same thing, okay? All right, what if the square roots are not all the same? Well, we can't add them together, right, if they're not all the same. However, if we can reduce them, then maybe we could. So for example, the 18, I can split that up into 9 times 2. The 32, I can split that up into 16 and 2. And the 72, I think, divides by 36. Yes, it does. 36 times 2. So now what I'm going to do is simplify. So I've got the 2's right here that are still in the front. Okay, and I'm going to take a new color. Square root of 9 is 3. Square root of 16 is 4. And square root of 36 is 6. And then I still have those square root of 2 left over, square root of 2 left over, square root of 2 left over. Notice this piece, we haven't talked about this before. When you take that out, you're multiplying those two numbers together. So this turns into 6 root 2 plus 8 root 2 plus 6 root 2. So this one was pretty easy because you didn't have to worry about that. But these two, that's a new concept, okay? So 6 plus 8 is 14 plus another 6, so this, my final answer is 20 root 2. So if you're adding or subtracting and they're not all the same, try to reduce them, and then once they're fully reduced, then if they're all the same like this guy was, you can combine them all, or maybe some of them are the same and you combine some of them. Please don't assume that they're all going to combine into one answer, okay? You might get an answer that looks like this guy where some of them combined and some of them don't, okay? All right, what about multiplying? Multiplying is a little bit different. Multiplying is like for this first one, I want to do 5 times 10, which is 50, but I still have the square root. The way I think of it is if I had square root of 50, you might split it up into this number times this number to get to here. So now we're just kind of going the other direction and putting it back together. But here's the last little twist. 50 can be split up into 25 times 2, and we can make that 5 root 2 by reducing. Okay, so it's adding a little extra twist right there. So let's say you've got that same idea, but you have numbers in the front. Okay, what I do is I'd still draw those same arrows. So square root of 2 times square root of 6 gets me square root of 12. And then 3 times 2 gets me 6 in the front. So now the last thing I need to do is check, well, square root of 12 can be reduced, right? We can write that as 4 times 3. So that turns into 6 times 2 times square root of 3, because 3 kind of stays trapped in there. So my final answer is 12 root 3. These two down at the bottom, I just want to show you examples of these guys. They're very, very similar, but notice how we're distributing. So we have to do 3 root 2 times this first number. So 3 times 4 gives me 12. And square root of 2 times square root of 3 gets me square root of 6. Then, I'm switching my colors so you can see what I'm doing. Then I'm going to do that same first number times this one. So 3 times 6 is 18. Square root of 2 times square root of 2 is square root of 4. So I can't reduce square root of 6, but square root of 4 is just 2, right? So 18 times 2 is 36. And then I still have this 12 root 6 in the front. So that would be my final answer, okay? Don't forget, you can also write it this way. That is totally fine. So you can write it in a different order. That does not bother me at all, okay? So let's try this last one, okay? 5 times 3 gets me 15. And the square root of 3 times square root of 2 gets me square root of 6. If I distribute again, I go 5 times and I kind of hesitate because there's not a number in front of that square root of 3. Well, remember, there's secretly a 1 right there. Oh, that looks like a terrible 1. You guys know what I mean. So 5 times negative 1 is negative 5. And square root of 3 times square root of 3 is square root of 9. So this I can't reduce at all, but 9 is the same thing as 3. So then I get 15 root 6 minus 15, or don't forget, you can put the minus 15 in the front and put the radical in the back. That's totally fine, as long as you're being careful with your symbols, okay? All right, you guys, so tomorrow you will get assigned homework number 2 that's all about these square root operations. So spend some time going through this video, practicing some of these questions, stop by and see me for office hours so that your assignment tomorrow goes a little faster if there are things you're still struggling with, okay? Good luck, you guys.